increase in temperature. So when there is rise in temperature, what will happen? So with rise in temperature, the rate of diffusion of particles increased, the random motion of particles increased, and hence the kinetic energy increases. So kinetic energy increases with rise in temperature, right? So these are the points that you should know. The first 3 points are most important characteristics of problem. Hello children, let's begin with a wonderful chapter, Matter in Our Surroundings. Children, in this chapter we will be dealing with the properties of matter, physical states of matter, that is solids, liquids and gases. We will distinguish them, and also we will understand the interconversion of these physical states of matter. So let's begin with the wonderful chapter. So first of all, I would like you to emphasize here that these are the various examples I have. But what do they have common? See, rain, people, soda, sun, bell. What? Sun is also here. Then we have crayons, glue, syrup, helium. Where is helium? Helium is there in the balloon. Then we have computer, rocket, lemonade, smoke, books, steam. Lot of examples I have here on the screen. Right? Milk, saucer ball, hot air, flowers, hat, ice. Then I have gasoline, oxygen and pear, all the fruits and even smoke. What is common in them? Do you find anything which is common in them? Yes, they have one thing in common, and that common thing is matter. Yes, they all contain matter. So the question arises, what is a matter? So even, have you seen solids? Yes, there are a lot of solids around you, right? When you are sitting here in the room and listening to the chapter and watching the video, are you actually using some solids? Yes, there are solids around you. And do you drink water? Yes, I drink water every day. I'm sure you also drink water every day. I'm sure you also drink milk, lemonade and many other liquids, right? And gases, do you inhale oxygen? Do you exhale carbon dioxide? Yes. So all these solids, liquids and gases, they also are matter. Yes. So the question arises, what is matter? So children, matter is defined as something that occupies space and has mass. So when you look at the picture again, do you see particles here? These tiny particles, they have mass. Yes, they do have mass. They also occupy some space. Do they occupy space? Yes, look at them. They occupy space. So when they occupy space, that is, they occupy some volume and they have certain mass. Ice has certain mass, water has certain mass, water vapors have certain mass. So definitely they have certain mass and they occupy space. So that's why they are matter. Because matter is defined as anything that occupies space and has volume and mass. So as per Indian philosophers, children, the matter is classified on the basis of 5 elements, and those 5 elements are known as Panch Tattva. So children, the question is, what is Panch Tattva? Children, Panch means 5 and Tattva means elements. So everything around you, it is classified under 5 main categories. And those 5 main categories are 5 elements, and those are air, water, then earth, that is land, right? Fire. And the last one is, any idea? Yes, it is sky. I'm sure many of you have said wind, right? So air, water, earth, fire, sky. These are the 5 main elements which are categorized for matter. Now, everything around us is a matter, as you know that. So Indian and Greek philosophers, they confirmed that everything, whether it is living or non-living, is made up of these Panch Tattvas, right? There must be either smoke, which is fire, it could be land, or which is earth, it could be water, or it could be wind, which is sky, or it could be oxygen, carbon dioxide, or other gases, which is air. So definitely the matter is further classified by the modern scientists on the basis of its physical properties and chemical properties. So we will understand the properties of matter on the basis of their physical nature in the next video. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this interesting question. The question says, which of the following is a matter? So we have a lot of options given. What about chair? Is chair a matter? So I'm sure that you know that matter. What is matter? What is the definition of matter? Matter occupies space, right? It is anything that occupies space and has mass. So you have to think whether the given substances, whether the given options occupy space. Do they have mass? So what about chair? Definitely chair occupies space and has mass. So it is definitely a matter. Air? Yes, air occupies space. How? Think about when you inflate a balloon. You put air in that, right? Helium gas or any other gas. So when you put gas in the balloon, definitely balloon inflates. It means that air occupies some space and yes, it has mass also. So it is a matter. Love is a feeling. It's not a matter. It does not occupy space, right? So love is not a matter. Smell? It is really an interesting question. Children, smell is a matter. Yes, it's a matter because when we talk about the fragrance moving from the incense stick, it contains smoke particles. It contains volatile particles or smoke particles which move from one point to the other. That's why smell is definitely a matter. What about hate? Again, hate is a feeling. So it does not occupy space and has mass, so it's not a matter. What about cold? When you feel cold, you feel it, right? It means it's a feeling again, so it's not a matter. Lemon water, it occupies space. When you put in glass or a jar, it occupies space and has mass. So lemon water is a matter. Again, we have a smell. Smell of perfume. It contains fragrance. It contains volatile substances which move from one point to another. So smell of a perfume is a matter. Thought is just a feeling. Again, it's not a particular matter because it cannot occupy space and has mass. So it's not a matter. Almonds, definitely they occupy space and have mass. They are solids. So it is a matter. I hope you have understood. Thank you. Hello children, let's understand this very interesting question. It's a reasoning question, a very important question as per examination point of view. So the question says, give reason for the following observation. The smell of hot sizzling food reaches you several meters away. But to get the smell of cold food, you have to go close. It's a very practical question, right? You can see it in everyday life that it happens. So when you have a cooked food at home, a hot sizzling food, the smell reaches to your nose immediately even when you are in the separate room. Why? Because when you are talking about hot sizzling food, there is temperature, right? There is more temperature. More temperature, what will happen? There will be more kinetic energy. So if there is higher kinetic energy, what will happen to the particles? So if there is higher value of kinetic energy, the motion of the particles will be higher. That's why there will be more random motion of the particles. Yes, the particles will intermix quickly. So they have more random motion of particles and hence we can smell the food, the fragrance of the food, we can feel or smell several meters away. But what about the cold food? So when we talk about cold food, definitely the particles have less kinetic energy because we are not heating it. So it has less kinetic energy, and that's why the motion of the particles is comparatively less, and we can't smell it from the faraway distance. We have to come closer to the cold food in order to smell it. I hope you have understood. Thank you. Hello children, let's understand this wonderful question. The question says, a diver is able to cut through water in swimming pool. Which property of matter does this observation show? So what is happening here? We are talking about water. Diver is able to cut the water. How? Because it's very simple that water is a liquid. Yes, what is the physics? Hello children, let's begin with a wonderful chapter, Matter in our...
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this interesting question. The question says, which of the following is a matter? So we have a lot of options given. What about chair? Is chair a matter? So I'm sure that you know that matter. What is matter? What is the definition of matter? Matter occupies space, right? It is anything that occupies space and has mass. So you have to think whether the given substances, whether the given options occupy space. Do they have mass? So what about chair? Definitely chair occupies space and has mass. So it is definitely a matter. Air? Yes, air occupies space. How? Think about when you inflate a balloon. You put air in that, right? Helium gas or any other gas. So when you put gas in the balloon, definitely balloon inflates. It means that air occupies some space, and yes, it has mass also. So it is a matter. Love? Love is a feeling. It's not a matter. It does not occupy space, right? So love is not a matter. Smell? It is really an interesting question. Children, smell? Smell is a matter. Yes, it's a matter because when we talk about the fragrance moving from the incense stick, it contains smoke particles. It contains volatile particles or smoke particles which move from one point to the other. That's why smell is definitely a matter. What about heat? Again, heat is a feeling. So it does not occupy space and has mass, so it's not a matter. What about cold? When you feel cold, you feel it, right? It means it's a feeling again. So it's not a matter. Lemon water? It occupies space. When you put in glass or a jar, it occupies space and has mass. So lemon water is a matter. Again, we have a smell. Smell of perfume. It contains fragrance. It contains volatile substances which move from one point to another. So smell of a perfume is a matter. Thought is just a feeling. Again, it's not a particular matter because it cannot occupy space and has mass, so it's not a matter. Almonds, definitely they occupy space and have mass. They are solids, so it is a matter. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this very interesting question. It's a reasoning question, a very important question as per examination point of view. So the question says, give reason for the following observation. The smell of hot sizzling food reaches you several meters away. But to get the smell of cold food, you have to go close. It's a very practical question, right? You can see it in everyday life that it happens. So when you have a cooked food at home, a hot sizzling food, the smell reaches to your nose immediately even when you are in the separate room. Why? Because when you are talking about hot sizzling food, there is temperature, right? There is more temperature. More temperature, what will happen? There will be more kinetic energy. So if there is higher kinetic energy, what will happen to the particles? So if there is higher value of kinetic energy, the motion of the particles will be higher. That's why there will be more random motion of the particles. Yes, the particles will intermix quickly. So they have more random motion of particles and hence we can smell the food, the fragrance of the food, we can feel or smell several meters away. But what about the cold food? So when we talk about cold food, definitely the particles have less kinetic energy because we are not heating it. So it has less kinetic energy and that's why the motion of the particles is comparatively less and we can't smell it from the far away distance. We have to come closer to the cold food in order to smell it. I hope you have understood. Thank you. Hello children, let's understand this wonderful question. The question says, a diver is able to cut through water in swimming pool. Which property of matter does this observation show? So what is happening here? We are talking about water. Diver is able to cut the water. How? Because it's very simple that water is a liquid. Yes, what is the physical state of water? It has a liquid state. And what happens in liquid state? What about the particles? The force of attraction between the particles is comparatively less, right? So when we talk about interparticle forces of attraction, are they less or more? So interparticle forces of attraction are less and interparticle spaces are comparatively more as compared to solid state. So the diver can easily cut the water and can pass through the water in the swimming pool. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this wonderful question. The question says, what are the characteristics of the particle of matter? We know that there are three main important characteristics of particles, though there could be more, but the first one that we can write is the particles of matter are very tiny. They are very small particles, right? Then what could be the second point? The particles are in continuous motion. Yes, right? They are in continuous motion. What is the third and important property of matter, children? That particles attract each other. Yes, the particles attract each other. Then when they are in continuous motion, do they possess some kinetic energy? Yes, whenever a substance or anything is in motion, we definitely say that they possess kinetic energy. What is kinetic energy, children? The energy possessed due to its motion. It is kinetic energy. And what about increase in temperature? So when there is rise in temperature, what will happen? So with rise in temperature, the rate of diffusion of particles increase, the random motion of particles increased, and hence the kinetic energy increases. So kinetic energy increases with rise in temperature, right? So these are the points that you should know. The first 3 points are most important characteristics of properties of matter. If the question is of only 3 marks, write only first 3 points with one example. I hope you have understood. Thank you. Hello children, let's understand this very important topic of the chapter. It is states of matter. Yes, do you know that the matter can be classified on the basis of physical properties? And by the physical states, we can say that there are solids, liquids and gases. So matter is divided into 3 classes: solid, liquid and gas, on the basis of their physical properties. So any guesses? Which one is solid, liquid and gas? So the kind of arrangement, as you can see here, the particles are tightly packed. Definitely it is solid. When we talk about liquids, they don't have a rigid shape, right? So the particles are comparatively loosely held. So it is liquid. And in gases, they can easily flow. So the particles are loosely held and therefore this is gaseous structure, right? The particles arrangement belongs to gases. So let's talk about solid, liquid and gases one by one. So when we talk about solid state, children, solid state has definite shape and size, right? So think about this pen. Is it solid in state? Definitely yes, it is solid. So the particles have definite shape. Yes, you can see it's a pen. It has a definite shape. Suppose if it is in triangle shape, do you say that it is pen? No, we can't say that it's pen. So usually the particles are arranged in a rigid manner, in a proper arrangement such that they have definite shape and size and they have negligible compressibility. Can you compress this? Let me try. No, I can't compress it. I can't compress this even I apply force. But then many students will say that I can compress sponge. Yes, I know you can compress sponge because sponge has tiny holes. Though it is a solid, but it has tiny holes where air goes inside the holes and we are able to squeeze the sponge. As soon as we apply pressure on the sponge, air particles come out and we are able to compress it. But the rigid solids like this pen, like this remote, they are not compressible. They have negligible compressibility. Can my pen flow? No, it can't flow, right? So they do not flow. And when external force is applied, solids frequently retain their shape. For example, rubber band. See, it is expanding, it is stretching. But again, when we are removing the force, it is again coming its to original shape. Right? So solids frequently retain their shape. So now when we talk about their structure, look at their structure. This is solid, right? What kind of structure do they have? Because of their special arrangement, they are tightly packed. They are rigid because they can be broken under pressure, but it is difficult to change their shape, right? I can't change the shape of my pen. I can cut it, but by compressing, I can't change the shape. How much force I should apply? And what about the interparticle spaces? Do you see that the particles are very closely packed? So if the particles are very closely packed, the interparticle spaces is least in solids as compared to gases and liquids. And what about force of attraction? Because they are very closely held, they have greater force of attraction. So the interparticle forces of attraction is very high in solids. Now let's understand by an activity the properties of solids. So in this activity, we will observe that solid state has definite shape, boundary and fixed volume. So what are we going to do? We will collect the following articles: a pen, a book, a needle, a piece of wooden stick. So 4 samples we will take. We will take a pen, book, needle and a wooden stick. Sketch the shape of the above articles in your notebook by moving a pencil around them. Check their shape and volume. So what will you find? That they all have definite shape. Needle has definite shape, wood has definite shape, pen, book, they have their own shapes, but they have a definite shape and volume. Then what happens if they are hammered or pulled or dropped? Are these capable of diffusing into each other? Can you diffuse pen in book or book in pen? No, I can't. Try compressing them by applying force. Are you able to compress them? Are you able to compress my pen or your pen? No, it is not possible. So what are the observations of the activity? So the observation is book gets torn when pulled apart. Pen and wooden piece break on hammering. Pen tip may break when dropped. On compressing, their shape does not change. When mixed together, pen, wooden piece and book do not diffuse or intermix. They do not intermix with each other. So what is the conclusion? The conclusion of the activity is all these particles have fixed shape, they have fixed size, they have definite volume, and these particles cannot be compressed or diffused into each other. I hope you have understood that how solids have different properties. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello students, let's understand another physical state of matter, and it is the liquid state. So, I'm sure you have seen many liquids in your life, right? Water, we drink it daily. Milk, oil, you have seen. Kerosene oil, petrol, you have seen. Alcohol, and many more liquids you may have seen. So, let's see this water. You can pour water in any of the container, right? Does water has its own shape? Definitely not. It has no shape on its own. So, is it taking the shape of the container? Yes. Right now here, it is taking the shape of the glass. So, you can pour water in any of the container. It will take the shape of that container. It means water has no shape on its own. So, definitely, they neither have fixed shape nor size, but they have fixed volume. Can I take 100 ml of liquid? Can I take 10 ml of liquid? Can I take 1000 ml of liquid? Yes, I can measure the volume of the water or any liquid. So, the amount of water I am taking, I can calculate. So, they have fixed volume, but they don't have fixed shape. They take the shape of the container in which we are pouring them. Now, the particles of solid, liquid and gases can diffuse in liquid. Think about when you put salt in water. What will happen? When you put salt in this water, will it mix? Yes. Sugar? Yes. Potassium permanganate, copper sulfate crystals? Yes. So, solids can easily dissolve in water. Now, think about liquid. Think about alcohol. Can alcohol dissolve in water? Yes, it will also dissolve in water. Then what about a gas? Think about seawater. When we talk about aquatic life, which gas is present in aquatic life? Definitely, they contain dissolved oxygen in water. Yes, so gas can also dissolve in water. Think about cold drinks, the aerated drinks. So, what is there in cold drinks? The soda water. carbon dioxide is present in water, right? So can I say that gas also dissolve in water? Yes. So particles of solid, liquid and gases, they can easily diffuse or dissolve in water or any liquid as per their nature. Now they can flow. Can they flow? See, water is flowing down. So that's why we call them fluids. And are they rigid? No, they are not rigid. So definitely they are not rigid. Now the next property is, look at the structure of the arrangement of the particles in liquid state. They are comparatively loosely held as compared to solids. So the interparticle spaces are more in liquids as compared to solids, but less than gases. What about the force of attraction? Solids have stronger force of attraction because the particles are tightly packed, right? Liquid particles are loosely held, so their forces of attractions are comparatively less than solids. Now let's discuss the activity where we will observe that liquids can flow and take the shape of the container. So what are we going to do in the activity? Collect the following samples. Collect water, cooking oil, milk, juice, cold drink or any other liquid that you have. Containers of different shapes. Put 50 ml mark on these containers using a measuring cylinder from the laboratory. What will happen if liquids are spilled on the floor? Will they spill? Then measure 50 ml of any one liquid and transfer it into different containers. One by one, does the volume remain same? So you can take a long container, a short container but a widened surface area and mark 50 ml on each. Do you think when you put water in a long container or in the saucer pan or a bowl having 50 ml mark, will the amount of water remain same in all of these? Then does the shape of the liquid remain same? When you pour the liquid from one container into another, does it flow easily? So what are the observations? So I'm sure that this activity is really easy and it is a daily life activity, I should say, right? So you can perform it not in the laboratory but at your home. So what will happen? The observation is the liquids such as cooking oil, milk, water, juice and cold drink, it definitely flow on the floor when spilled. On pouring fixed volume of these liquids in different containers, the volume remains same. When you are taking 50 ml of water, you can pour it in any container, it will remain 50 ml, right? It will not disappear or increase in volume. All these liquids can take the shape of the container. And oil flows more slowly than water. Now the question arises, why oil flows slowly than water? It also depends on the density. So children, oil has higher density than water. So if it has higher density, it is comparatively more viscous. So the particles take time to flow, right? Now, what is the conclusion? So can we say that liquids have fixed volume? They have indefinite shape. There is no fixed shape. They take the shape of the container, right? But they have fixed volume. They can flow easily. However, the density of oil is more than water, so it flows slowly. I hope you have understood. Now, there is very important note that you should know that what is this? Aquatic life, right? So, due to the dissolved oxygen and carbon dioxide present in the water, in the seawater, these species can sustain underwater. So, can I say that gases can also dissolve in water? Yes, like carbon dioxide and oxygen, they dissolve in water, and that's why the whole aquatic life, the plants and animals, they can sustain. They can do respiration or photosynthesis. Consequently, we can say that solid liquids and gases can diffuse into liquids. Now, there is another very important point to note that compared to solids, liquids diffuse at a faster rate as their particles are in more random motion, as the particles in liquid state move comparatively freely and have more interparticle spaces between them than those of solid state. So, the particles in liquids, They are in more random motion. They can easily move here and there as compared to solids which have rigid structure. So if I ask you that can we write solid, liquid, gas in an order of their motion of the particles? Yes, let's do that. So according to the motion of the particles in solid, liquid and gaseous state, which has more motion, which has more random motion of the particles, the answer is gas. Because particles are loosely held with each other. They have least force of attraction and they can easily flow. So gases have more motion of particles than liquid, and solids have minimum motion of the particles due to their rigid structure. I hope you have understood. Thank you. Hello children, let's understand the physical properties of gaseous state. So the third and very important state of matter after solid and liquid is gaseous state. So have you seen any gas around you? I'm sure you have seen. This entire air contains oxygen, nitrogen, carbon dioxide and many other traceless gases, right? So what about the air? When you talk about the air, do you see it? No, we can just feel it, right? So does it has a fixed shape? No, definitely no. So gaseous state or gases, they don't have fixed shape. So they neither have fixed shape nor fixed volume. And can we compress them? Yes, we can compress them. How? Think about when you have inflated the balloon. What will happen? Can you compress it? Yes, we can compress the balloon and by that way air will come out. So definitely we can compress the gas easily. And what about the carbonated water? What happens in soda water, children? How do you pour carbon dioxide in water? Because you know that carbon dioxide is a gas. Particles are in random motion. How can it go and fit into the liquid? Because again, there is high pressure. So when we compress them, when we put high pressure, it leads to dissolution or dissolving of the carbon dioxide in water to make soda water. Yes. The interparticle force of attraction are the least in gases as compared to liquid and solids. The gas particles move randomly here and there and create pressure on the walls of the container and also between them. The rate of diffusion is maximum in gas as compared to liquid and solids because particles are in continuous motion. Their force of attraction is less and they are far away from each other, which leads to higher rate of diffusion of gaseous particles. Yes. So that's why the fragrance or the aroma of the incense stick which is lit is easily moving towards us even if we are standing far away in the room. Now, there is a very important keynote here that we can smell the aroma of cooked food even we are away from the kitchen. Why? Why is it so? This delicious smell of the food, this is cooked food, and this smoke particles which you can see here, these particles of aroma diffuse in the particles present in the air. So these particles of aroma, they easily mix in with the air and by the process of diffusion, they move from one position to the another and hence they reach to us easily and they spread from the kitchen and hence reach us. So there is another very important point here that there are gases which we can compress and use them. How? So children, as we know that gaseous particles are highly compressible. So we compress these gases and make CNG, right? What is CNG, children? The full form of CNG is compressed natural gas. Children, natural gas contains mainly methane. So we compress it and then we use it as a fuel. You know that CNG is a very good fuel. Then we use LPG. Where is LPG used? In our kitchens, right? So the full form of LPG is liquefied petroleum gas. So we have compressed the petroleum gas and made it in the liquid form by compressing it. That's how we use it for the fuel in the kitchen. Now we have also compressed oxygen to the liquid form. So we get liquid oxygen. And I'm sure you know that liquid oxygen is really important in the hospitals, right? So these are the common examples of compressed gases that we use in daily life. Their large volume is compressed in small cylinders for easy transportation. So you should know, why do we compress them? So that it is easy and convenient to transport them from one place to another. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this very important activity. The activity will explain to show that gases are highly compressible as compared to solids and liquids. So we will try to compress solid, liquid and gas, and we will see which is more compressible and which is less. So what do we do in the activity? Take 300 ml syringes and close their nozzles by rubber corks. Remove the piston from all the syringes. Leaving one syringe untouched, fill water in the second and pieces of chalk in the third. Insert the pistons back into the syringes and try to compress the content by pushing the pistons in each syringe. So it's a very simple activity. You can do it even at home. You have to bring 100 ml syringes. Keep one untouched because then there will be air in that, which is a gas. Then put water in the second and chalk in the third, and then apply pressure using piston of the syringe. So in order to observe the activity, let's watch an animated video.
To show that gases are far more compressible as compared to liquids, take a syringe, remove its plunger outward. Close the nozzle of the syringe with a plastic cork. Fill half of the syringe with water. Now, push the plunger inward with maximum force and record your observation. Stop applying force and again record your observation. The plunger does not move inward on the application of force. When the force is removed, the plunger does not move backward. Reason: liquids have small intermolecular spaces, thus they cannot be compressed. Take another syringe. Remove the plunger outward. Close the nozzle of the syringe with a plastic cork. Fill half the syringe with air. Now, push the plunger inward with maximum force and record your observation. Stop applying force and again record your observation. The plunger moves downward to a considerable length on the application of force. When the force is removed, the plunger moves backward and takes its original position. Reason: gases have large intermolecular spaces. Thus, they easily get compressed on the application of force. The compressed gases are under high pressure. When the force is removed, this high pressure forces the plunger back to its original position.
So children, as you have seen the animated video, I'm sure it is very interesting. So what are the observations that we have seen? That the piston of the syringe, when is left untouched, can be easily pushed inward because it contains air, right? So we have not filled anything in the first syringe. It means there is air in that, right? Because air takes the space when there is nothing there. So it means the syringe which contains air can be compressible, right? So can I say that gas is compressible? Yes. What about the syringe of chalk and water? While the syringe with pieces of chalk cannot be compressed. It's a solid, rigid structure. How can we compress it? Then the piston can be moved very little in the case of water filled in syringe, because then water will come out, right? So it is difficult to compress even water. But when we compare all the three, air is the most compressible. So what is the conclusion? The conclusion is gases are highly compressible. The matter in the liquid state is comparatively less compressible, while matter in the solid state cannot be compressed at all. I hope you have understood this. Now, it is really important to understand that interparticle arrangement of the state of matter. So, we have three states of matter, right? What are these three states here? This is solid. See, the particles are very tightly packed. They are so close to each other that their motion is restricted to a particular shape, right? So, they are though in motion, but they are restricted. They are in a rigid structure. But what about liquid? This is liquid. When we talk about liquid, see, the particles have comparatively more motion because the interparticle spaces are more, the force of attraction is less. About gases, look at the wonderful gaseous particles. So these gas particles, the particles have minimum force of attraction as compared to solid and liquid, and their spaces are too much that they can easily move here and there in a random motion. So the particles of gases are in more random motion than liquids and solids. So this is how the arrangement of particles happen in solid, liquid and gases. I hope you have understood. Thank you. Hello children, let's understand this very interesting question. The question says, the mass per unit volume of a substance is called density. What is density? Mass upon volume. Arrange the following in order of increasing density, and the options given are air, exhaust from the chimneys, honey, water, chalk, cotton and iron. Children, keep it in mind that it is given that we have to write in increasing order. What is the meaning of increasing? From the lighter density to the highest density. So, among these which have lightest density, which is not at all denser, it is gas. We should know that gas has less density than liquids. Liquids have less density than solids. Why I am saying that solids have more density as compared to liquid and gaseous state? Because it depends upon the mass per unit volume. That in a particular volume, how many particles exist. So, we know that in solids, particles are so close that there are more particles that can exist in a particular volume. Comparatively less particles exist in liquid and very less particles exist in gaseous state in a particular volume. So, children, let's arrange all these given options here. So, first of all, what about gas? Which one of these are gases? We know that air and exhaust from chimneys are gases, but exhaust contains smoke particles, right? So, comparatively, it is denser than air. So, the least density belongs to air. Then, there will be exhaust from the chimney because it has more density due to the smoke particles present in it. Then, what about liquid? We have honey and water in liquid. Then, we have chalk, cotton and iron. It is very surprising to know that cotton has less density than water. Yes, it has less density than water because cotton has porous structure. So, the air traps inside the porous structure of the cotton and hence it leads to lesser density of cotton. Then among honey and water, water has less density and honey is comparatively viscous. Then the next is chalk and iron. I'm sure you know that iron is more denser. It is hard and rigid. So definitely chalk, and then iron has the maximum density. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this very interesting question. It's a very important question as per examination point of view. Children, the question says, tabulate the differences in the characteristics of states of matter. So we know that there are three states of matter, solid, liquid and gases. So we will differentiate between them on the basis of the characteristics. So you should know the characteristics and the differences. So first of all, when we talk about shape and size, what is the shape and size of solid? They have a definite shape and size, right? What about liquid? Indefinite shape, right? Why do we say they have indefinite shape? Think about water. Water has no shape. It takes the shape of the container in which it is poured. What about gases? They also have indefinite shape. What about volume? Solids have definite volume. Can we calculate the volume of a liquid? Yes, they also have a fixed volume. So they have definite volume. Gases, we say that they have indefinite volume. If you see air, can you calculate the volume of air? No. But yes, we can actually measure the volume of a particular gas when it is kept in a particular container, which is closed container. Now, when we talk about nature, solids are rigid and hard, right? While liquid is fluid and gas is highly fluid, right? It can flow easily. Then the next is interparticle spaces. Solids have minimum, least interparticle spaces because particles are very closely packed. They have moderate or medium interparticle spaces because they have more spaces than solid and less spaces than gases, and they have maximum spaces between particles. What about attraction? Because the particles are very closely packed in solids, they have maximum or highest force of attraction. This is again medium or moderate, and this is minimum force of attraction between particles of gases. What about diffusion? Solids do not diffuse, right? They don't diffuse among each other's particles, but they do diffuse in liquid and gases. Liquids, they definitely diffuse, and gases, definitely they diffuse. What about compressibility? Solids have negligible compressibility. Liquids have less compressibility. And what about gases? They have high compressibility. I hope you have understood. There is another part of the question. It says, comment upon the following: rigidity, compressibility, fluidity, filling a gas container, shape, kinetic energy and density. Now children, let's proceed with the B part of the question. The question says, comment on the following. So we have a lot of options given here. First part is rigidity. Do you know out of solids, liquids and gases, which among them has more rigidity? So definitely the answer is solids. Solids are rigid, right? Solids are rigid. So children, now let's proceed with the B part of the question. The question says, comment on the following. So we have various parts given in this particular part, where the first is rigidity. So do you know children that solids, liquids and gases, which among them is more rigid? Definitely, think about this pen. It is very much rigid. It is hard and it has a definite shape and volume. Similarly, the remote, and hence we can say that which objects are rigid? Those which are solid in state. So solids are rigid. Now what about compressibility? When we talk about compressibility, we know that solids have particles very close to each other and therefore they are incompressible. But liquids can compress a bit, but gases, they are highly compressible. Why they are highly compressible? Because their particles are very far away from each other. So compressibility belongs to gas. Gases are highly compressible, right? They are highly compressible because The particles can come close to each other in gases as they have lot of spaces between them. Now when we talk about fluidity, can solids flow? No, my pen cannot flow. So solids are not fluids. Liquids and gases can flow. So fluidity belongs to liquids and gases. Right? Now what about filling a gas container? So how can you fill a gas in a container? The answer is really easy, by applying high pressure. Yes, so when you apply high pressure, the particles come closer to each other and we can fill the gas in the container the way we make soda water. We pressurize the gas particles so that they come close to each other and fill in the spaces of the liquid particles. Now what about shape? Which substances have fixed or a definite shape? Definitely the answer is solids. Solids have definite shape and they have definite volume, but liquids and gases, they do not have definite shape. Liquids take the shape of the container in which we pour them. Now what about kinetic energy? Kinetic energy is maximum in gases. Why it is maximum in gases? Because particles are in more random motion because of weaker force of attractions between the particles. Then liquids, and the least kinetic energy is in the solids. Why? Why they have least kinetic energy? Because the particles are so close to each other that they have stronger force of attraction such that the particles are moving but not continuously. There is some vibrations going on between the particles, but there is no continuous random motion that we can see. What about density? Which particles are closer to each other? Definitely in solid state. So in solid state, particles are closer to each other. So density is mass per unit volume. So in a particular volume, the number of particles are more in case of solid. So definitely the density of solid is much higher than liquids, and gases have minimum density. Right? I hope you have understood. Thank you. Hello children, let's understand this very important topic. As we were discussing about matter, it is very important to know that we can further understand the matter, the properties of matter on the basis of physical nature. Yes. So what is the physical nature of matter? Is it a particle nature or is it a continuous nature? For that, let's understand what was the history of the matter. So many scientists believed that the nature of matter is actually continuous. That is, it is continuous like a block of wood. But there were scientists who believed that matter is actually like a sand, the particles. So there could be continuous nature like moving continuously, or in the form of small particles like sand particles. So what was actually the truth? So the truth was, children, that matter is made up of very tiny particles. Yes, they are particles. So these particles, as you can see here, solid particles, how rigidly they have arranged, very close to each other. Or in the gases, the particles are very far away, and in liquid, the particles are not so close and not so loosely packed, so they are arranged. But they have particles in them, right? Particles here, particles here, particles here in spherical structures as we are showing you. So it means we can say that matter is made up of very tiny particles and not a continuous block. They have small particles arranged in a particular shape. Yes. So in other words, matter is a particulate in nature and not continuous. So matter is not continuous. It is in the form of particles. There are small particles in every matter. There are millions of particles in the small matter. For example, this pen, it has lot of particles in it. This remote has lot of particles in it. Even human body has lot of particles in it. So definitely matter is made up of very small tiny particles like the one you can see here in the image. Particles in the solid are very close to each other. Particles in liquid are comparatively less closer, and in gas particles are far away from each other. But yes, they contain particles. Now, there is an activity to prove that matter is made up of particles. So, how will we prove that matter contains particles? So, let's see this video. We are adding salt to the water and it is dissolving, right? Such a simple activity. But the question arises, the water level is not increased, right? So, where is this salt gone? And if it is dissolving in it, then where it is occupying this space? So, let's understand the property that matter is made up of particles. So children, for this activity, a very simple one, what you have to do, you have to put a small amount of sugar or salt particles in water with the help of a glass rod or stirrer, right? And observe the changes. So what are the changes that you will observe, children? That the sugar or the salt is completely dissolved, right? So where is the salt gone? And where does the sugar particles gone if we mix sugar or salt in it? So the answer is very simple and logical. So what did we observe? We observed that when some amount of sugar or salt particles are dissolved in water with the help of a glass rod, the level of water in the beaker remains same, right? Isn't it very surprising that you are adding something in water but still the level of water is not increased? It is still the same. How is it possible? The particles of sugar or salt have spread throughout the water, right? As you can see here, the particles are spreading throughout the water particles, right? So how is it possible? Where is the space? So children, the conclusion is the very small particles make up matter. How? So to understand that, let's understand the arrangement of atoms or the matter in the liquid. So when we talk about water, children, water contains, this is suppose the arrangement of water molecules, right? Because it's a liquid, the particles are not too loose or too closely packed. So they are moderately loosed, right? So there are some gaps here. Do you see? There are some gaps. So in the gaps in between the water molecules, there are spaces, right? So in these spaces, salt particles can fit. Why? Because they have very small size. So these sugar or salt particles, they can fit into the water spaces, the spaces or the interparticle spaces present between the water molecules where the sugar or salt can be present. So when we mix both of them, the particles of salt or sugar have spread throughout the water and the level of water did not rise up. And hence it proves that there are spaces in the particles, and also it proves that the particles are very tiny, right? They are very small in size. I hope you have understood the activity and the concept. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this very interesting reasoning question. The question says, a gas fills completely the vessel in which it is kept. Is it true? Definitely, because particles are in random motion. These gas molecules, they have high kinetic energy. Why they have high kinetic energy? Because particles are in random motion. And what about the force of attraction between them? Yes, they have weaker forces of attraction. So due to their weak forces of attraction, the particles are loosely held and they can easily occupy the container, and therefore gas fills completely in the entire vessel. It occupies the entire space of the vessel. Now the B part says, A gas exerts pressure on the walls of the container. Again, definitely it is so, because they have weaker force of attractions such that they collide with each other. And this collision leads to more kinetic energy. Ke means kinetic energy. So they have kinetic energy which leads to bombardment within the particles and bombardment with the walls of the container. Now the C part says a wooden table should be called a solid. Why should we call a wooden table solid? So if you see a table, does it has a definite shape? Definitely it has a definite shape. So if it has a definite shape, and what about volume? Yes, it has definite shape and definite volume. So it is a solid. Not only that, it has a rigid hard structure, right? Now what about the D part? We can easily move our hand in air. Like this. Can you move your hand in air? Yes, even I can do that. But to do the same through a solid block of wood, we need a karate expert. Absolutely right. Because air is a gas, right? Air is a gas. And gas molecules have weak forces of attraction such that we can easily pass our hand through it. While when we talk about a solid block, a solid wooden block, as we say, it is solid. So when we talk about a wooden block, it is solid. And the particles are so closely packed and it's such a hard and rigid structure that we cannot pass our hand through it. And we need a karate expert to apply a lot of force in order to break the force of attraction, in order to overcome the force of attraction between the particles. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this very interesting question. The question says, liquids generally have lower density as compared to solids. But you must have observed that ice floats on water. Find out why. So, we know that if the particles have higher density, for example, solids, they usually have higher density. So, if they have higher density, that is more mass per unit volume, they sink, right? They sink in water. They don't float in water. But the question here says, why ice floats on water? Children, ice has a different structure, though it is a solid, but it has a cage-like structure. Yes, because of the cage-like structure, it has many spaces or many voids in between the particles such that it has less mass and more volume. So comparatively, it has lesser density. So if it has lesser density than water, it floats on water. So keep it in mind, children. Ice has cage-like structure having many voids or spaces such that less mass is there per unit volume. So it has lesser density and it floats on water. I hope you have understood. Thank you. Hello children, let's understand this very interesting topic, and the name of the topic is, can matter change its state? So have you ever converted water into ice in your freezer? I'm sure you have done that. And have you ever seen your mom boiling water? Yes, and these days we even boil water in the kettles, right? So can matter change its state? Definitely yes. So what is the meaning of interconversion of matter? Children, the meaning of interconversion of matter means we can convert one physical state into another. Can we convert solid to liquid? Definitely we convert solid to liquid state. Think about 3 physical states of H2O. H2O means water. It exists as water in the liquid state, but ice in the solid state and steam in the gaseous state, right? Which we also call it as water vapor. So, can you convert ice into water? Yes, definitely we can do that. We even keep ice at the room temperature. It starts melting. What did I say? Melting. So here the process we use is melting. Do we say ice melts? Yes, ice melts. Then what about converting liquid to gas? Can we convert liquid to gas? How can we make steam from water? We can do that by boiling. Yes. Can I say water boils? Definitely yes. Water boils. So, boiling is the term. So, gaseous state, we have water vapor or steam, right? So, can I say that we have 2 main terms here for interconversion of matter? Yes. So, what are those 2 terms, children? The first term is melting. What is the meaning of melting? When we convert solid state to liquid state, we call it melting. Ice melts to form water. Then what about boiling? The second term is boiling. Water boils in order to form water vapors or steam. So, liquid to gas, the process is boiling. Solid to liquid, the process is melting. Can we reverse it? Yes, we can also reverse the process. We can convert solid to liquid. We can convert gas to liquid. How? Can we convert liquid to solid? Yes, we can convert water to ice by freezing it. So the term here is freezing, right? And can you convert gas to liquid? Can you convert water vapors back to water? Have you ever heard about water cycle? I'm sure you must know water cycle. So what happens to the water vapors in the air? They condense to form water. So here the name of the process is condensation, right? What do we call it? Condensation. So definitely ice can be converted to water, water can be converted to steam. So any idea what is the process of ice to water? Yes, we are melting it. So the process is melting, right? And can we convert it back? Yes, water can be frozen back to ice. So the process is freezing. Can we convert water to steam? Yes, water to steam is, what is the process? Boiling. Yes, it is known as boiling. And can we convert steam back to water? Yes, we can again do that. Steam can be condensed back to water. So the name of the process is condensation, right? We can condense it to water. So water vapors can convert to water, water can convert into ice, and they can be converted back again. Is this interconversion of matter going on? Yes. We are changing the physical state by changing the temperature or changing some physical conditions. Then can we say that is it really possible in daily life? Yes, because we can do that for ice, water and water vapors. And not only that, whenever we cook food or whenever we apply such conditions to any of the physical state of solid, liquid and gas, we can achieve the interconversion of matter. So the question arises, how do we achieve it? So the first point, how are we achieving it? While boiling, am I heating the substance? Yes, I am heating the water in order to provide it sufficient thermal energy or temperature in order to convert into water vapors. Not only that, we can also apply pressure in doing so. How? Let's study temperature and pressure effect on physical change one by one. So first of all, there is change in temperature. Second is change in pressure. So interconversion of matter is possible by 2 different means. It can be achieved by changing the temperature and it can be achieved by changing in pressure. So let's understand them one by one. So children, when we talk about effect of change of temperature. So we have an activity to understand in detail that how temperature affects the interconversion of state of matter. That is, we can convert solid to liquid and liquid to gas. For that, the activity has the aim to study the conversion of ice to water, means solid to liquid, and water to its water vapor by heating. That is, liquid to gas by heating. So are we doing the change in temperature? Yes. Heating means changing the temperature. So what we have to do? We have to set up the given apparatus. These are the apparatus we have. So set up the given apparatus and note the temperature changes taking place in the thermometer. So as you can see in the first image, the apparatus we have contains thermometer, a glass stirrer, beaker containing ice. And we are heating it. How? By keeping it on Bunsen burner, right? By keeping it on tripod stand, having a wire gauze, and Bunsen burner is heating it. So there will be a temperature change. We will note down when the ice will start melting and when the complete ice has melted. And similarly, for conversion of water to vapors, we have the same apparatus. But here we don't have ice. Rather, we have water as a sample in the beaker. Again, we have a glass stirrer for uniform mixing. And there is a thermometer to note down the temperature readings. Again, when the water will start boiling, we will measure that temperature, and we will also observe the temperature when the water has completely boiled or evaporated. So let's watch an animated video in order to understand the activity better.
To study the change of state of ice to water, half fill the beaker with ice cubes and place it over a wire gauze and a tripod stand. Suspend a Celsius thermometer from the iron stand such that its bulb is well within the ice. Place a glass stirrer in the ice. Record the temperature of ice. You find that it is 0 degrees Celsius, 273 K. Now heat the beaker on a low Bunsen flame and continuously stir the contents of the beaker. Record the temperature 5 to 6 times till all the ice melts. You observe that the temperature remains 0 degrees Celsius, 273 K throughout, till all the ice melts. To study the change of state from water to steam, half fill the beaker with water and place it over a wire gauze and tripod stand. Suspend a Celsius thermometer from the iron stand such that its bulb is well within the water. Place a glass stirrer in the water. Record the temperature of water. Heat the beaker on a low Bunsen flame and continuously stir the water with a glass stirrer. Go on recording the temperature till water starts boiling. Allow the water to boil for a few minutes and record its temperature. You notice that the temperature of water rises till it starts boiling. The temperature of boiling water is 100 degrees Celsius, 373 K. If we continue heating the water, it changes to steam, but the temperature remains constant, that is 100 degrees Celsius, 373 K. Note, the temperature of boiling water may not be 100 degrees Celsius, 373 K, because the boiling point also depends upon the atmospheric pressure, the height of a place from the sea level, etc.
Children, as you have observed the activity, I am sure it is really interesting to understand the activity. So what were the observations that you have seen? So the observation is that the temperature is 0 degree. When it is 0 degree? When the ice starts to thaw or melt, right? The way I said, we will observe the temperature reading when the ice will start melting. So ice will melt at 0 degrees Celsius, right? The temperature remains constant at 0 degree until all ice has melted. Yes. So when ice started melting, the temperature is 0 degree. And when the entire ice has melted, Still, the temperature remains same, which is 0 degree. But we have not stopped the burner. The burner is still working. We have not stopped heating it. So it means, where is the energy going on? Where is the energy being used or utilized? So the entire energy is utilized in transformation of physical state from solid to liquid. Now, the temperature begins to rise after the ice melts completely. After reaching 100 degrees Celsius, the temperature begins to rise again. So what happens at 100 degrees Celsius? The water has started converting into water vapor. So what are the conclusions? So can we say that heat supplied during the melting of ice is utilized in the change of phase from solid to liquid? Children, keep this in mind. It is really very important and interesting point that whenever we convert solid to liquid, yes, how it happens? How do we achieve this? We achieve this by heating. And how do we heat it? By applying some temperature, by heating with Bunsen burner, right? So while converting solid to liquid, we can do that, and for that we need heat. And what happens at what temperature ice starts melting? At 0 degrees Celsius, ice converts into water, right? Though the value of this temperature is different for different substances, but in case of ice, it is 0 degrees Celsius. The ice starts melting at 0 degrees Celsius, and though we are continuously heating the substance, the ice with the burner, still the temperature remains 0 degrees Celsius until the ice melts completely. The question is, why is it so? Why the temperature has become constant, though I am heating it, right? The reason is that the entire solid particles, what is the type of arrangement they have? The particles are very close to each other, right? The particles are tightly packed. And what happens in the liquid state? Any guesses? What will happen to the liquid state? The particles are loosely held. So when we talk about liquid like this, the particles are not too much close to each other. So the entire energy is utilized in separating or moving the particles far away from each other such that they acquire liquid state. See the difference in the arrangement of these particles. In solid particles, the particles are so tightly packed and there are strong force of attractions. But in liquid state, the particles are far away from each other comparatively. So when we heat and ice starts melting at 0 degrees Celsius, until the entire ice melts, the temperature, the heating that we are giving, the thermal energy that we are supplying is utilized in overcoming the force of attractions, and this leads to separating the particles, moving the particles far away enough in order to attain the liquid state, right? So what do we call such temperature and the amount of heat required to convert solid to liquid? It is known as heat of fusion, latent heat of fusion. What is the definition of heat of fusion? The amount of heat absorbed in the process of melting of ice or converting solid to liquid is known as heat of fusion. Now, similarly, the heat supplied during the vaporization of water, the same thing happened when water starts boiling. And the same thing happened when the water starts boiling. So, as we know that water is a liquid, right? So, what happens to the particles? Particles are little far away from each other, like this. But when we talk about water vapors, what happens to water vapor? The water vapors have particles far away, very far away from each other. And do you know when water starts boiling? It starts boiling at 100 degrees Celsius. So we have seen that the transition of liquid to gas started at 100 degrees Celsius. But till the entire water converts into water vapor, though we are still heating it, the temperature did not change. it remained as 100 degrees Celsius only. Why is it so? Again, the reason is similar as that of ice to water, because the particles are closer to each other. They are not so far like gas. So the energy, the thermal energy that we supplied by heating is used up in overcoming the forces of attraction of the liquid particles, which helped in the particles to move away from each other in order to attain water vapor state, in order to attain gaseous state where the particles are so far away from each other, right? So the heat supplied during the vaporization of water is utilized in phase transition from liquid to vapor of the water. So what is this energy known as, which is required to convert water to water vapor? It is heat of vaporization. So the amount of heat consumed in the vaporization of water is known as heat of vaporization. It's not only for water. For this activity we are talking about water, but this heat of vaporization and heat of fusion is the property of all the physical states of matter. For solid to liquid, it is heat of fusion. For liquid to gas, it is heat of vaporization. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand a very important topic of conversion of solid into liquid. So what happens and how it happens that we can convert solid to liquid? So what is the theory behind it? So we know that solid particles are very close to each other, right? It is like this. The particles are so close to each other. But in liquid states, particles are comparatively far away from each other, though in continuous motion, but they are little far away from each other. So we need to provide sufficient energy to these particles so that they can break their force of attraction in order to achieve the liquid state, right? This arrangement is for solid state and this arrangement is for liquid state. We need to convert solid to liquid. And how are we going to achieve? By heating, right? So we will heat. So the kinetic energy of the particles increases with increase in temperature. Will this happen? So when you heat these particles, what will happen to them? They will attain some energy. That thermal energy will convert into kinetic energy and particles start moving, right? So the kinetic energy of the particles increases with increase in temperature of the solid and begin to vibrate faster, like this. Particles are vibrating, but on heating, they will have thermal energy which will lead to change in kinetic energy and the particles will vibrate fastly. So the energy provided by heat overcomes the forces of attraction between the particles. Hence, the particles leave their fixed positions and begin to move freely. Thus, solid changes to liquid state. And what do we call such temperature where this process happens when solid converts into liquid state? Such temperature is known as melting point. So what is melting point, children? Melting point of a solid is the minimum temperature at which it melts to become a liquid at the atmospheric pressure. So the process happens at atmospheric pressure. So it is the temperature when solid converts into liquid at the atmospheric pressure. It indicates the intensity of the force of attraction between its particles. What does that mean? So if a substance has a lower melting point, it means that it requires less energy to convert into liquid state. While if the substance is higher melting point, it means it requires more energy to convert into liquid state. It means, so the substance which has higher melting point has greater forces of attractions between them. That's why it took more energy in order to convert into liquid state. I hope you have understood. Now let's talk about the conversion of liquid to gas. Yes, the way we convert solid to liquid, we can convert liquid to gas also. And the theory behind the conversion of liquid to gas is almost similar. So here what happens? When a liquid is heated, the particles begin to move even faster. So see here, the particles were moving in liquid, but on applying heat can be written like triangle. So see here, the liquid particles are though moving, but the gaseous particles are moving so frequently, so faster. It is because when we heat, then the forces of attractions are overcome by the heating and they acquire kinetic energy in order to move even more freely. So they attain gaseous state. When a liquid is heated, the particles begin to move even faster to break out from each other's force of attraction, and the liquid begins to transform into gaseous state. The boiling point, so there is a temperature where liquid converts into a gas, and it is known as a boiling point. So boiling point of a liquid, keep in mind, melting point is for solid, where it melts. Boiling point is for liquid, where it boils. So boiling point of a liquid is the temperature at which vapor pressure of the liquid becomes equal to atmospheric pressure and a liquid starts boiling. Children, it is very important to learn the correct terms and definitions. It is important to know the correct terminologies. I hope you have understood. Now, what is boiling all about? Boiling is a widespread and a bulk phenomena. Why we call it a bulk phenomena? Because it happens within these particles, right? So it's a bulk phenomenon. Particles from the liquid bulk obtain enough energy to transition into vapor state, right? So when we are heating the liquid particles, they acquire sufficient energy in order to overcome the forces of attractions which they have, and they start moving away from each other, having sufficient kinetic energy and convert into gaseous state on heating. Now, what is the definition of latent heat of fusion and latent heat of vaporization? Because we are already talking about melting, freezing, we are talking about vaporization and condensation. So, what is the correct definition of the term latent heat of fusion and the definition of latent heat of vaporization? So, children, what do we mean by latent heat of fusion? So, the quantity or the amount of heat energy necessary to convert 1 kg of a solid into liquid at atmospheric pressure. So as we know that solid can be converted into liquid by heating. So how much amount of heat is required to convert solid to liquid? And specifically we have a reference point here. Take 1 kg of the solid. So how much energy or how much heat energy is required in order to convert 1 kg of solid to liquid at atmospheric pressure? Such amount of heat is known as latent heat of fusion. And similarly, what is latent heat of vaporization? Again, it is the similar term. So it is the quantity or the amount of heat energy necessary to convert 1 kg. Again, see, there is a reference point, 1 kg of a liquid into a gas at atmospheric pressure during its vaporization. So vaporization means converting liquid to gas. So how much energy is required to convert 1 kg of a liquid to its vapor state at its atmospheric pressure? This is latent heat of fusion. Children, learn the correct terminology. I am repeating this. It's really important. They are very important topics. Now, there is an important note here. Keep it in mind that the particles in steam, I'm sure you will be surprised to know that the particles in steam at 100 degrees Celsius or 373 Kelvin have more energy than the particles of water at same temperature. So if there is a question, which causes severe burns? Is it steam or boiling water? You must be thinking they are same, right? Because boiling water has steam. So children, it is really important to know that steam causes severe burns as compared to boiling water. Yes, I'm sure it is very new to you. It is because that steam at 100 degrees Celsius has more kinetic energy. It has more energy than the particles of water at the same temperature. So the boiling water has comparatively particles which are still in liquid state, right? But the steam, which is water vapors, the particles are in gaseous state. Where is more kinetic energy? Definitely water vapors have more kinetic energy. So though boiling water and steam exist at 100 degrees Celsius, but steam causes more severe burns because the particles have more kinetic energy, more energy as compared to the boiling water. So for this reason, steam causes more burns than boiling water. I hope you have understood. Thank you. Hello children, let's understand a very interesting activity. And do you know that we can convert solid to gas directly? Yes, we don't need to convert it into liquid state. There are solids which can directly convert into gaseous state without even coming to the liquid state. And the reverse is also possible. Gas can directly convert into solid without converting into liquid. Again, it is possible. So let's understand the process by an activity, and the activity is to observe sublimation of camphor or the ammonium chloride. So children, there is a term called sublimation. What is sublimation? The process that I am talking about, converting solid to gas directly without achieving the liquid state. So there are substances like camphor, like ammonium chloride, which can actually sublime, which can directly convert from solid to gas, and they don't even turn up at the liquid state. So what we will do in this particular experiment, we will take an inverted funnel like this, right? We will set up the apparatus in this way, where we have a burner, a tripod stand, we have a china dish in which we have camphor, and there is a funnel which is inverted, there is a cotton plug, and we are adding, and we are going to heat the substance. So what we will do, take some camphor, crush it and put it in a china dish. The way we have done here, we have taken a china dish and we have put powdered camphor in it. Then put an inverted funnel over the china dish, put a cotton plug on the stem of the funnel. See, we have put a cotton plug on the stem of the funnel. Now heat slowly and observe the changes. So before proceeding further, let's watch an animated video we have.
Sublimation of ammonium chloride. Place about 2 grams of ammonium chloride in a dry hard glass test tube and plug its mouth with cotton wool. Clamp the hard glass test tube in an iron stand and heat it gently on a spirit lamp. In a few moments, ammonium chloride sublimes, forming dense white fumes which fill the whole tube. Stop heating and allow the test tube to cool. It is seen that the dense white fumes slowly disappear and a fine white powdery deposit of ammonium chloride sticks to the side of the test tube.
So children, as you have seen the animated video, it is very much clear as per the diagram which you have seen that the particles will solidify here at the neck of the inverted funnel, right? So this is camphor solidified, right? And there are camphor vapors that we will see in the funnel. How is it so? Where is the liquid state? There is no liquid state, children. Solid converts into vapors, and then vapors condense back to solid state. Yes, they will directly convert into solid state and solidify at the neck of the funnel. So ammonium chloride or camphor on heating vaporize directly. They don't go to liquid state at all and get deposited on the inner walls of the funnel neck. So what is the conclusion of the activity? Camphor and ammonium chloride can sublime on heating and changes to gaseous states directly. On cooling, they deposit or desublime to the solid state. So this activity actually proves that yes, there is a process known as sublimation, or there is another term called desublimation, where you will see that the particles can convert from solid to gas and gas to solid directly. So what is the term known as? Children, the term is sublimation, and the another term is desublimation or deposition. So let's understand what is the correct definition of sublimation. Children, sublimation is the process of conversion of solids into gas on heating directly without changing into liquid state, right? And there are certain substances which can sublime. Which are those substances? Ammonium chloride can sublime. Camphor, we also call it kapoor in Hindi, it can sublime. Iodine can sublime. Naphthalene balls, have you ever heard of naphthalene balls? Yes, we use it to keep the winter clothes, right? So that we can store it nicely. So these substances, ammonium chloride, camphor, iodine, naphthalene, they directly change into gaseous state on heating without converting into liquid state. So there is a reverse term. What we know that solid to gas is known as sublimation. And there must be a term for the reverse process. When gas converts back to solid, what do we call it? We call it desublimation or deposition. The solid deposits on the neck of the funnel, right? So it is the process of turning a gaseous substance into a solid after cooling without transitioning to a liquid state, right? I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand very interesting topic. It is units of temperature. So, do you know that there are two main scales that we use for measuring the temperature by using thermometer? We have degree Celsius. What do we call it? Degree Celsius. And we have K. K means Kelvin scale. Though there is one more which is degree Fahrenheit. It is also being used, but usually we talk about degree Celsius and Kelvin scale. So what is the conversion of degree Celsius to Kelvin? It is 0 degree Celsius is 273.15 Kelvin. Though we don't use 0.15, we just use 273 Kelvin for easy calculation. But still you should know the correct or the actual term. It is 273.15 Kelvin. So there could be a questions related to this particular equation, that is 0 degree Celsius to 273 Kelvin. The question could be like, convert 100 degrees Celsius to Kelvin scale. How will you do that? Can you convert 100 degrees Celsius to Kelvin? Yes. For that, if 0 degree Celsius is 273, you just have to add the temperature in Kelvin can be written as whatever the temperature given to you. So for that, what will you do? The temperature in Kelvin to be calculated will be written as temperature which is given to you. So I'm writing T given. Just add 273 to it. For example, if you have 100 degrees Celsius, so just add 273 to it and it is equal to 373 Kelvin. So, can I say that 100 degrees Celsius is equal to 373 Kelvin? Absolutely yes. So, the idea is, If you want to convert degree Celsius to Kelvin, just add 273 Kelvin to it. I hope you have understood. Now there is a very important summary of the interconversion of state. Let's also do that. So how can you convert 3 states of matter? So if you have liquid, solid, and gas. So you have these 3 states of matter, right? So what are the processes that you will follow to convert solid to liquid and liquid to solid? Similarly, liquid to gas and gas to liquid, and solid to gas, gas to solid. What will you do? Which will be the processes required for it? So first of all, let's talk about solid to liquid. To convert solid to liquid, think about ice to water. I will melt the ice, right? So the process is melting, right? And how will you convert water back to ice, liquid to solid? By freezing it. So we will apply freezing method. Now to convert liquid to gas, what will you do? Evaporation or vaporization, right? We will vaporize. So the idea is to vaporize these liquid substances to convert into gaseous state. How will you convert gas to liquid? By condensation, right? We will condense it. So I'm just writing condense, but the correct process is condensation. Now solid to gas, how will you do it? Directly, without converting into liquid state, we will do sublimation. The process is sublimation. And gas back to solid without converting into liquid is desublimation or deposition. Right? The name of the process is desublimation or deposition. Hello children, as we have already understood how temperature affects the interconversion of physical states from solid to liquid, liquid to gas. Now let's study about the effect of change of pressure on physical states. How pressure converts physical states from solid to liquid to gas. So for this, we should know that the gas liquefies when high pressure is applied. Yes, we can easily liquefy any gas. Think about CNG. What is CNG? Compressed natural gas, where natural gas has been compressed in order to liquefy it and use it as a fuel. Think about LPG, liquefied petroleum gas. The term is liquefied. So petroleum gas has been liquefied in order to use it as a fuel. So LPG is also compressed by applying a high pressure to liquefy it. Similarly, liquid oxygen, oxygen gas is converted to liquid state, and by the process of applying pressure, we have put it in the oxygen cylinders. So the gas liquefies when high pressure is applied to it. Now the question arises, how pressure affects to it? So when you see this, the particles of gases are far away from each other, and we can apply pressure to them by the piston. What do we call it, children? We call it piston. So what happens when piston is applied? So this is a cylinder where we have kept the particles of gases, and we are applying the pressure by applying piston. So by pushing this piston, what will happen? See, the particles are far away from each other. See their distance. But now by applying pressure, pressure is equal to force per unit area, right? So by applying more pressure means we are applying more force per unit area. So by applying more force means the particles will come closer to each other, the distance will decrease between them, and the force of attractions will increase. So by applying more pressure means the force of attraction between the particles increases, right? Force of attraction between particles increases, particles come closer to each other. So when particles come closer to each other, what will happen? They will definitely change their state. So, and we apply more pressure. See, particles are very close now, and they will change their state from gas to liquid to solid. So this can also be achieved when the temperature is reduced. This is how pressure affects the interconversion of states of matter. Now, What about carbon dioxide? Children, you should know that carbon dioxide exists as a gas at room temperature. But we have solid carbon dioxide also. Yes, and we call it dry ice. What do we call it, children? Dry ice. Now, this CO2, which is gas, it can also convert into CO2 solid directly, which is dry ice. And it is achieved by applying high pressure. So when you apply pressure, again, what will happen to the carbon dioxide gaseous particles? The particles will come closer to each other because of more forces of attractions generated between them, and they turn into a solid carbon dioxide. So the solid carbon dioxide is stored under high pressure. The solid CO2 gets converted directly into gaseous state. So we can convert solid CO2 back to the gaseous state. How? By heating it. Right? By applying heat energy, we are able to provide sufficient kinetic energy for the particles to move far away from each other. So, can we say that when we increase the temperature, the particles go away from each other? And when we increase the pressure, the particles come closer to each other. Right? So, solid CO2 gets converted directly into gaseous state on decreasing the pressure to 1 atmosphere without changing into liquid state, and hence solid carbon dioxide is also known as dry ice. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this wonderful question. The question says, convert the following temperature to Celsius scale. So the first is 300 Kelvin. How can we convert 300 Kelvin into degree Celsius? So we have a very small formula that Kelvin is equal to degree Celsius plus 273. Now in this particular equation, we need degree Celsius, right? When we need the temperature in degree Celsius, put the value of Kelvin here, which is 300 Kelvin given in the first part. So can I say degree Celsius is Kelvin minus 273. So the Kelvin value given is 300 minus 273. And what is the answer, children? It is 27 degrees Celsius, right? Now what about 573 Kelvin? Again follow the same formula. So degree Celsius is Kelvin minus 273. So what is the value of Kelvin? 573 minus 273. So what will be the answer, children? It is 300 degrees Celsius. I hope you have understood. Thank you. Hello children, let's understand this wonderful question. It says, what is the physical state of water at 250 degrees Celsius? Children, we know that 250 degrees Celsius is much higher temperature than the normal boiling point of water. What is the boiling point of water? 100 degree. It means at 250 degrees Celsius, water has already boiled. So, what is the physical state of water? It exists in gaseous state, right? In the form of water vapors, right? Water exists as water vapors. Now, what about 100 degrees Celsius? Children, at 100 degrees Celsius, it's the boiling point of water. It means it is the temperature at which water is converting into water vapors. So both the states exist. As water it exists, as water vapor it exists. So when it exists as water, it means the state is liquid state. And when it exists as water vapors, it exists as gaseous state, right? So we have both the states at the same temperature, which is 100 degrees Celsius. I hope you have understood. Thank you. Hello children, let's understand this wonderful question. It's really an interesting question and very important question as per examination point of view. The question says, for any substance, why does the temperature remain constant during the change of state? So whenever solid is converting into liquid, right? And whenever liquid is converting into gaseous state, I'm sure that you know that when in the case of water, if we are talking about solid, when convert to liquid, it occurs at 0 degrees Celsius. We are specifically talking about water here in order to understand better. And liquid to gas occurs at 100 degrees Celsius, which is the boiling point of water, right? Now, what happens when solid starts converting into liquid? The ice starts melting. So during the melting point, which is 0 degrees Celsius, what is happening? The temperature that we are supplying to the particles, that thermal energy converts into kinetic energy and it overcomes the forces of attraction between the particles, and particles move far away from each other in order to attain liquid state. The same process happens at the boiling point. What happens at the boiling point? When we talk about water, the particles are still closer to each other. They are not too far as compared to gas. So liquids have still some forces of attraction which are needed to be overcome in order to convert into gaseous state. So what happens? So in the liquid state, as the particles are closer, again the thermal energy is required to overcome those forces of attraction so that particles go far away from each other and hence they convert into gaseous state. So what is the point here? Where is the thermal energy used? So the thermal energy is required to overcome the forces of attraction between the particles. Right? I hope you have understood. Thank you. Hello children, let's understand this very important concept of matter. Children, how small are these particles of matter? So how can we find out that particles of matter are very small? So for that, we should know that the size of particles is so small that it is difficult for us to comprehend. We cannot comprehend the size. It's so small, it's so tiny that even you cannot hold it. If I ask you bring one particle for me, no, it is not possible for you. You can't bring one particle for me. So children, the size of the particle of matter is so small that it is difficult for us to even comprehend. So what are these? These are the particles of matter. But can you guess which one is solid, liquid and gas? So children, solid, have you seen solid? These are solids. The particles are so tightly packed such that they have a rigid structure, right? A fixed shape. It has a fixed shape. It has a fixed shape. I have a fixed shape. I am solid. So the particles in the solid, they have fixed shape because they have fixed arrangement such that their particles are very close to each other. So these are solids. What about this? The particles are little far away from each other but not very loosely held. So this is liquid, right? And what is this? The particles are loosely held and they even try to escape from the container because this is gas. But they all contain particles and these particles are very small. Do you see particles in water? No, I can't see. Do you see particles in this? No, I can't see any particle in this. It's just it has a beautiful grey color with black nib, right? But I can't see any particle in it. I can't take out a particle from it because it's so small that you can't even see from the naked eyes. You definitely need a microscope to even visualize the particles. So children, solid, liquid, gases, they all contain particles in certain arrangement, but these particles are very small in size. So there must be an activity to prove that the particles are very small in size. So the activity is there are millions of tiny particles present in matter. Millions of particles, right? So what do we do in the activity? We will first of all dilute the solution of potassium permanganate. Children, potassium permanganate is KMNO4 and it is beautiful dark purple coloration crystals. So we will take 2 to 3 crystals of potassium permanganate that is KMNO4, and we will put it in 100 ml of water, right? So take few crystals of KMNO4, these are dark purple colored crystals, and put them in 100 ml of water. So this is the dark color solution you will get. So as you can see, it is a dark purple color only. It's 100 ml water. Now take 10 ml of this solution, and that 10 ml is poured in again the remaining 100 ml of water in another beaker. Now, do you see the change in the color? Why? Because we have added more water to it. So there is dilution going on. What is the meaning of dilution or dilute? Children, dilute means we are adding more water. So we are actually taking 10 ml of this solution, and that 10 ml we are pouring it in another 100 ml of water. So is the water content increasing? Yes. So that's why I'm saying we are diluting the solution, means we are increasing the content of water. Now the color is different. It is not dark purple. It is sort of magenta, right? Now take 10 ml of this solution and put it in another 100 ml of water. See, the color is again changing to pinkish. Now take again 10 ml of this solution and put it in the next 100 ml of the beaker. So see the water color. The color of water is again changed. It is very much light pink in color. So the question arises, what is happening here? Why there is a change in color going on, and why the color of KMNO4 is not disappearing? Right? We just added 2 to 3 crystals of KMNO4, but still, see, we do have a color, some color. It's not a colorless water now. When we poured this 10 ml to the water, the particles should have gone, but no, you can see the particle colors even here also. The color has not vanished. So why is this so? So can I say the observations are, on adding more water to the solution of potassium permanganate, the color of the solution becomes light but still visible, right? Do you still see the color? Yes. So the color is still visible, though it is light shade now. So what is the conclusion? So can we say that each potassium permanganate crystal consists of millions of minuscule particles that can continuously divide into smaller and smaller particles? Is it so? Yes, because we just poured 2 to 3 crystals in this 100 ml beaker, and see how intense the color is. It means the crystals have lot of particles, such that when you put them in water, the millions of the particles, they segregated or they spread all over the water. And then when we taken out 10 ml of it and poured it in other water, again those particles spread out throughout the water. Then we took that 10 ml in the another beaker containing 100 ml water. Again, the particles, they spread throughout the water. Again, they spread out throughout the water, but particles are still there. So it clearly indicates that there are millions of minute or small sized particles that continuously divide into smaller and smaller particles. Hence, we can say that there are tiny particles present in matter. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand the question. The question says, suggest a method to liquefy atmospheric gases. So children, yes, we can liquefy atmospheric gases by applying high pressure. So when you apply high pressure, the particles will come closer to each other and they will liquefy into a liquid state. And it can also be done by lowering down the temperature. So when you lower down the temperature, the kinetic energy of particles decreases. And when the kinetic energy of particles decreases, the force of attractions increase. Again, the particles will turn to liquid state. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this very interesting topic. The topic is evaporation. Have you seen evaporation in your daily life? I'm sure you must have seen evaporation. So what is happening here in this? So the water is converting into water vapors, right? How is it happening? By heating. So these water vapors are generated because of evaporation. So what is evaporation? Evaporation is the process in which liquids are converted into their vapors at any temperature below their boiling point. So before the entire water converts into water vapor, the steam which is produced, what do we call it? The process is known as evaporation. Yes, it's a very important term. There is some confusion between boiling and evaporation. Children, evaporation occurs below the boiling point. Because at the boiling point, entire water will convert into water vapor, right? But evaporation is the production of this steam taking place when we are continuously heating the water. Because when water is at room temperature, suppose 32 degrees Celsius, still we are heating it to attain 100 degrees Celsius. Boiling point will be achieved at 100 degrees Celsius. So what is happening between room temperature to 100 degrees? So during this increase in temperature from room temperature to 100 degree, there is heating going on, right? So water is converting into water vapor and this steam is produced and the process is known as evaporation. At 100 degrees Celsius, entire water will convert into water vapor and we will say that water is boiled, right? Now, there is an activity to understand what are the factors affecting evaporation. So, first of all, let's discuss the aim of the activity, which is to observe the factors affecting the rate of evaporation. So, in this particular activity, what are we going to do? First of all, we will take 5 ml of water in a test tube and keep it near the window or under the fan. Then, we will take another sample of 5 ml of water in an open china dish. Keep it in mind, here we are taking test tube, here we are taking open china dish and we are again keeping it under the fan or near a window. Again take 5 ml of water in open china dish and keep it inside the cupboard or a shelf in your class. Record the room temperature on rainy seasons. So you have to record the room temperature and on the rainy season, on the rainy days, and then record the time or the days taken for the evaporation process in above cases. So we have 3 cases, 5 ml of water in each case. First of all, we are taking in a test tube and we are keeping it near the fan or near the window. Then we are taking 5 ml water in the open china dish. We are again keeping it under the fan or near the window. We are taking 5 ml of the third sample of water which is kept in open china dish, but this time we are keeping it inside the cupboard or on a shelf in your class. So what will happen? So we have observed that water kept in the porcelain dish or the china dish near the window is evaporated in 30 minutes. While it took nearly an hour for water in the test tube to get evaporated. it took more than an hour for the water to evaporate in the china dish. So children, this particular evaporation is seen when it is a sunny day, right? But on wet days, on humid days, there is lot of water vapor around, right? So water takes more time. It takes almost double time to get evaporated because there is already water in the air, right? It is a humid air. So on wet days, the evaporation rate is actually slow. So what is the conclusion? The conclusion is the surface area important? Yes, surface area is very important. In the test tube, it takes more time to evaporate, while in china dish, which has larger surface area, water takes less time to evaporate. So surface area is important and wind speed is important. So if they both increase, if surface area increases and wind speed increases, the rate of evaporation increases. But what about wet days? When there is humid climate, when there is water in the air already, so those water vapors, they actually slow down the rate of evaporation. So the humidity, when it is increased, the rate of evaporation decreases, right? So can we say that what are the factors affecting evaporation? So there are four main factors which affect evaporation. The first is surface area. Larger the surface area, think about china dish and test tube. China dish has more surface area. That's why it takes less time to evaporate the water in the china dish. So larger the surface, higher is the rate of evaporation. That is why we spread the wet clothes for drying out, right? So wet clothes we usually keep on the rope where we spread the clothes, right? So why do we spread the clothes? In order to increase the surface area of the cloth so that the water can dry up quickly. Now, the second important point here is temperature. Another important factor that takes role or participates in the rate of evaporation is temperature. How does temperature affect? So, as you know that when we performed the experiment on the sunny day, the evaporation rate was higher. But when we did the experiment on the rainy day, the temperature was low, or in the winter season also, the temperature is low. So, the rate of evaporation decreases. Higher the temperature, the kinetic energy of particles increases and therefore higher is the rate of evaporation. Now the third factor affecting is humidity. We know that what is humidity, children? The amount of water vapor in the air is humidity. So if already air has water vapors in it, how will it have more water vapor in that, right? Evaporation rate decreases. So the rate of evaporation slows down if the air already contains a lot of water. Thus, in rainy season, clothes take time in drying, right? And the last factor affecting the evaporation is wind speed. So, higher the wind speed, what will happen? So, if the wind speed increases, then there will be higher rate of evaporation. Why? Why is it so? Because on a windy day, we will see that the water vapors, they move faster, right? So there is a space in the air where more water vapors can be accumulated. So that is why on a windy day, clothes dry faster. As the wind move away the particles of the water vapors from the surroundings, so more water vapors can be accumulated in the air and the rate of evaporation increases. I hope you have understood. Thank you. Hello children, let's understand this interesting topic. The topic is, how does evaporation causes cooling? So children, as you know that evaporation is a surface phenomena, right? What do we mean by surface phenomena? Phenomena means that there is a process going on, right? And if it is happening on the surface, because the particles will heat at the surface level, it will not directly heat from the inside, because we are not just heating it. In daily life, evaporation happens on its own by absorbing the heat from the surroundings. So when there is a hot, dry day, when there is a sunny day, what is happening? Sun is directly causing evaporation. So do you know that evaporation actually leads to cooling effect? Yes, it leads to cooling effect. How? Because the liquid in an open jar continues to evaporate by absorbing the energy from its surroundings. So this is what I said. It's a surface phenomena. So the surface liquid The liquid particles which are on the surface, they absorb heat energy from the surroundings and they get evaporated. So when they get evaporated, what happens? As a result, the surrounding temperature drops. So it causes cooling. Now, there are daily life examples that you would like to know that how evaporation is affecting in daily life. So the first is evaporation of sweat also keeps us cool. Do you know that? Sweating is useful for us. What? Yes, sweating is useful for us. It keeps us cool. How? So the particles at the surface of the liquid gain energy from the surroundings, as we already know, or the body surface during evaporation and change into vapors. So what happens during evaporation? The sweat which we have on our body, and when we sit under the fan, what happens? There is evaporation taking place. So the particles, they absorb energy from our body and we feel cool, right? So this in turn makes us feel cool. Now, another point here, which is a daily life example, is people sprinkle water on the roof or the open ground on a hot sunny day. Have you ever seen this? Yes, there are many people who does this, who don't have AC or cooler at their home. What they do? On their roof, they put water. They sprinkle water on a hot sunny day. Why is it so? Because water has high latent heat of vaporization. So it helps in cooling the scorching surface, the hot surface. So water absorbs all the energy, the heat energy, and makes the surface cool. Now, the next daily life example is when we pour some acetone on our palm. How do we feel? We feel cool. Yes. What is acetone? Acetone is a nail polish remover. So when we put some drops of acetone on our skin, we feel cool. Why is it so? Because acetone is a volatile substance. What do we mean by volatile substance? It has low boiling point. So it immediately converts into vapors. So because the particles of acetone gain energy from our palm from our body and evaporate, causing us a cooling effect. So that's why we feel cool. The next is, which types of clothes should we wear in summer season? Definitely, in summer season, we should wear cotton clothes. Yes. So cotton is a good fabric for summers. Why? Because it absorbs the sweat easily, remains loose, and thus allows movement of air through the holes in it. So what is the main point here? That cotton is a good absorber of sweat. Yes, not only that, it also allows the movement of air for rapid evaporation. So that's why we should wear cotton clothes during summer season. The next point is, I'm sure that you have seen a glass containing ice. Or you can do it even today at home. When you reach home or when you are already at home, take a glass, put ice in that. Keep it for some time undisturbed. You will find there are water droplets around the glass surface. Yes. So the question arises, is the water leaked from the glass container? No. Then how are these water droplets arrive on the surface of the glass container? So children, the water vapors are present in the atmosphere. So when there is low temperature in the glass container or glass tumbler, so what happens? Water vapors present in the air, when comes in contact of cool surface, they condense. So the temperature decreases, condensation happens. So water vapors, they condense into water droplets by losing their energy, and hence we can see the water droplets on the outer surface of the glass tumbler containing ice cold water or containing ice. I hope you have understood this. Thank you. Hello children, let's understand this very important and interesting question. The question is, why does a desert cooler cool better on hot dry day? So children, what is the condition given? Hot dry day. On this particular condition or during this type of season, there is low humidity level, right? The level of humidity is less. What do we mean by humidity, children? Humidity means that there is less amount of water vapors in the surroundings. So you know that humidity causes the change in evaporation rate. So if there is less humidity, what will happen? When there is low humidity, there will be more evaporation. Yes, the rate of evaporation gradually increases. So there is more evaporation and hence it leads to more cooling. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand the question here. The question says, how does the water kept in an earthen pot or matka become cool during summers? Yes, isn't an interesting question? Definitely yes, because I'm sure you have seen matkas or earthen pots. And have you ever tasted the water? It's so sweet and the point is it is cool. So the question is why the water becomes cool? It's not a refrigerator. So actually earthen pots have small pores. So these small pores are sufficient enough to put the energy inside the earthen pot, and that energy, that heat energy which is trapped inside the earthen pot helps the water to convert into water vapors. So these water vapors, when they are released from the pores, what they do? They create cooling effect. So water converts into water vapors and pores become those channels from where water vapors go out of the earthen pot and it creates cooling effect on the earthen pot. I hope you have understood. Thank you. Hello children, let's understand this question. The question says, why does our palm feel cool or cold when we put some acetone or petrol or perfume on it? So children, acetone, petrol and perfume, they are known as volatile substances. What do we call them? They are volatile substances. What is the meaning of volatile? That they have low boiling point. Now, if they have low boiling point, it means they vaporize easily. In other words, what do we say? They vaporize easily. They need less temperature to undergo vaporization. So, they vaporize easily. So, now as they vaporize easily, they require less temperature to boil. It means that they even take the heat energy from our body surface and that energy is sufficient for them to evaporate. Therefore, it leads to cooling effect on our body. I hope you have understood. Thank you. Hello children, let's understand this question. It says, why are we able to sip hot tea or milk faster from a saucer rather than a cup? Children, what is the difference between saucer and a cup? The shape, right? Saucer has large surface area, while cup has comparatively smaller surface area. So if saucer has large surface area, larger the surface area, greater is the rate of evaporation. So greater evaporation will happen. This will lead to cooling of the tea immediately in the saucer as compared to cup. So we are able to sip the tea from the saucer fastly as compared to cup because saucer has a greater surface area. It creates more evaporation and hence the tea becomes normal or at a normal temperature soon as compared to cup. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand the question here. The question says, what type of clothes should we wear in summer? Children, summer seasons, they lead to a lot of sweating, right? Lot of perspiration. So what should we do? We should wear cotton clothes, right? The question is, why should we wear cotton clothes? Because they are good absorbers. Yes, they are good absorbers of sweat. So they can easily absorb sweat. Not only that, the holes, the pores they contain allow the sweat to evaporate quickly. So that's why cotton is a better fabric to be used in the summer season. I hope you have understood. Thank you. Hello children, let's understand very important characteristics of the particles. So what are we going to discuss? That there are very important characteristics of particles of matter. So the first characteristic we have is particles of matter have space between them. Such spaces are known as interparticle spaces. What do we call them, children? We call them interparticle spaces. So the question is, where are the spaces? When we are saying that particles of matter have spaces between them, think about the activity where we dissolved salt or sugar in water. What happened? The point was, when we added salt and sugar in water, the level of water did not rise. Why? Because the salt or the sugar particles, they dissolve into the spaces. They took the positions or the spaces in the water molecules. So, for example, see this water molecules. This is water, right? So, there are particles in this. See, these are the particles of water molecules, right? Now, these particles are far away from each other. Do you see spaces between them? Yes, there is a lot of space in between them. So, these spaces can be occupied by other particles of matter because they are very tiny. So, when you put salt or sugar, they take the spaces here, right? They take all these spaces. So, the particles of salt, they can occupy these small spaces because they are very tiny. They are very small in size. And the level of the water does not rise up. It clearly indicates that even when we add salt or sugar or potassium permanganate, there are spaces in between the particles of water such that the salt can occupy the space in between the particles. It clearly indicates that there are spaces in the particles and the particles are very tiny. So, when you see this particular example, what do you see here? This dark purple coloration is because of KMnO4, right? It is potassium permanganate. Children, this potassium permanganate can easily dissolve in water because, again, if these are water molecules, when we see at the microscopic levels, there are interparticle spaces between them. There are spaces between them which are known as interparticle spaces. So, the potassium permanganate particles can also fit into the spaces between the water molecules, just like salt or sugar, and therefore it can easily dissolve in water. So what can we conclude? Can we say that there is enough space between the individual particles of matter? And what do we call such individual particles? Spaces, we can say that interparticle spaces, right? And can we say that one type of particles get fit into another particles? Yes. So here also it is happening. Salt is one type of particle. It is mixing into, it is taking the position into the other kind of particles, which is water. Hence, we can say there are spaces between the particles. I hope you have understood. Thank you. Hello children. As we know that we are discussing about the physical properties of states of matter, So here, when we talk about matter, they are particles. Actually, we already know that one of the important property of matter is they have spaces between them, right? That's why when you put salt or sugar in water, they easily dissolve in water, right? Because they occupy spaces between the water molecules, right? Now, the second characteristic of particle of matter is particles of matter are continuously moving. As you can see here, see the particles are randomly moving here and there in the particular physical state. Why is it so? Because when they collide with each other, they get kinetic energy. What is kinetic energy? Kinetic energy means the energy possessed due to motion. Are they in motion? Yes. So they have kinetic energy. And by this kinetic energy, they keep on colliding with each other and with the walls of container in which they are present. So due to the continuous colliding, there is a continuous motion, and that's why we say that particles of matter are continuously moving. Now let's understand an activity so that we can clearly see that how particles keep on moving. For that, the activity aim is to prove that particles of matter are in a state of continuous motion. So for that, what we have to do? Put an unlit incense stick in a corner of your class. So what is an incense stick? Agarbatti, right? So we take an incense stick which is unlit. We have not burned it right now. So it is an unlit incense stick. So how close do you have to go near it so as to get its smell? What do you think? I'm sure that you know that when you take an agarbatti or an incense stick and keep it at the corner of the room, if you are sitting very far away to the last corner of the room, it is very difficult to get its fragrance. But what about the lit incense stick? So now what you have to do? Light the incense stick. You get the smell sitting at a distance? Absolutely yes. So when you burn or you lit the incense stick, the fragrance will go through the air and will come and reach to you. So that's why even if you are sitting so far from the incense stick, you will be noticed that there is a beautiful fragrance coming from the lit incense stick. So to understand it better, let's watch an animated video.
To prove that the particles of matter are in a state of continuous motion, take out a fresh incense stick from a pack and fix it in a stand. Place the stand in the corner of a room. You will be able to smell its perfume. Now, slowly move away from the incense stick. You notice that you cannot smell the perfume. Now, light the incense stick and leave the room for a few minutes. On entering the room, you will be able to smell the perfume everywhere in the room. Let us try to answer the following questions. Questions. Why can you smell the perfume of incense stick? Why you cannot smell its perfume at a short distance when the incense stick is not lighted? Why does the smell of perfume of incense stick fill the whole room in a few minutes when lighted? Answer. The particles of perfume matter are not stationary but are continuously moving. They drift through the air and hence we can smell the perfume. The particles of the perfume matter do not have sufficient energy to drift through the air. Thus, we cannot smell it when we are at a few steps away from the incense stick. When the incense stick is lighted, the heat energy makes the particles of the perfume to move rapidly. Thus, they easily drift through the air in the room and hence we can smell it anywhere in the room. From the above activity, the following conclusions can be drawn. Particles of matter are in continuous state of motion and hence have some energy. When the temperature of matter rises, the particles of matter move faster. Diffusion. The intermixing of particles of two substances on their own is called diffusion. In the above activity, the particles of perfume diffuse into the particles of air on their own and hence we can smell them. When the incense stick is lighted, the particles of perfume have more energy. They diffuse rapidly in air present in the room, and hence we can smell them everywhere in the room.
So children, as you have seen the animated video, I'm sure it is really easy and interesting. What you have observed? We have observed that to smell the unlit incense stick, we have to come very close to it. While when there is a lit incense stick, it releases smoke particles, and those smoke particles diffuse in the air or mix with the air and reaches to us even when we are sitting so far from the particular incense stick. So a lit incense stick releases smoke particles carrying fragrance. So children, what is the conclusion? The conclusion is this shows that the particles are constantly in motion and they have kinetic energy. Because they are continuously moving, the smoke particles which are produced or released from the burnt incense stick, they are flowing through the air and reaching to us. Why? Because they have motion, they have kinetic energy. And what happens when we heat them? Because we are burning incense stick, we are providing thermal energy. So by supplying thermal energy, the movement of particles increases, the random motion increases, the kinetic energy increases, and cover a larger surface area. I hope you have understood the activity, and I'm sure that you know that the particles of matter are in continuous motion. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand a very interesting activity. In this activity, what are we going to do? We will study the diffusion of two different liquids in water. First of all, we should know a very important term here. What is that term? The term is diffusion. What do we mean by diffusion? Children, diffusion means intermixing of particles in order to mix throughout or uniformly. So, what is diffusion, children? Diffusion is the process of intermixing of particles of two different types of matter on their own. For example, when you put salt in water, it dissolves itself, right? The particles dissolve on their own. Do you need to put any kind of energy? No, you don't need to put any kind of energy because they dissolve, they intermix on their own. Now think about the lit incense stick. The smoke particles mix in the air particles, right? The smoke particles flow through the air particles by intermixing, by dissolving in each other and reach to us. So this is diffusion. The intermixing of particles is diffusion. Similarly here, ink is dissolved in the water. This is diffusion. Intermixing of particles. What is happening here? The particles are diffusing into each other. The particles are intermixing into each other. This is what we call diffusion. So, here is the activity to understand the process of diffusion, that yes, particles do intermix. How? So, the activity aim is to study the diffusion of two different liquids in water. For that, what we will do? We will take two beakers filled with water. Put a drop of blue or red ink slowly along the sides of the first beaker and put a drop of honey along the sides of the second beaker. Leave them undisturbed and record the observations. So what are the observations? For that, first of all, let's watch an animated video.
To study the diffusion of two different liquids in water, fill the dropper with blue-black ink. Allow one drop of the ink to trickle into the first beaker by letting it fall on the upper rim of the inner side of the beaker. Cover the beaker and leave it undisturbed for 4 hours. Make observations after every 15 minutes and record them. As the drop of ink trickles along the sides of the beaker, the blue color of the ink starts diffusing in water, which appears like wavy blue streaks in water. The ink spreads evenly in water in about 2 hours. In the second beaker, add a drop of honey on the inner side of the beaker and make observations as stated above and record them. The honey drop continues traveling along the side of the beaker and there is no visible diffusion of it in water. The diffusion of honey is very slow as compared to the diffusion of ink. It is because the honey is a dense liquid. Its particles have strong intermolecular forces as compared to water. Thus, it diffuses slowly in water.
Children, as you have seen the animated video, such an interesting activity is it, right? So the observations are, the ink takes few minutes to an hour, depending upon the amount of ink we are mixing, to spread evenly throughout the water, right? So it takes just few minutes for ink to mix uniformly in the water, right? It mixes quickly when added to water. Why? Because ink has less density than honey. So when we talk about honey, it is viscous. What is viscous? It has higher density than water. So honey being viscous moves downwards slowly. So what is the conclusion? The conclusion is that ink has density roughly equal to or slightly higher than water, but not too much higher. So its density is not too high than water, so it immediately mixes in water. So ink can easily dissolve in water. It can fastly dissolve in water. But what about honey? So when we talk about honey, honey has higher density than water. So it first sinks at the bottom and gradually mixes with water. I'm sure this is what you have observed in the activity in the animated video. I hope you have understood. Thank you. Hello children, let's understand a very interesting activity. The activity is to study the diffusion of a solid in water at room temperature and in boiling hot water. So we are taking two samples of water. One sample is water at room temperature. The another sample is water which is boiling, which is hot, right? So what we are going to do in the activity, drop a crystal of copper sulfate or potassium permanganate into a beaker containing hot water and in another beaker containing cold water. Do not stir the solution. Allow the crystals to settle at the bottom and observe the changes. So what are we going to do in the activity? We will take the crystals of copper sulfate or we will take the crystals of potassium permanganate, which are dark purple crystals, right? And we mix them in water, in two different samples of water, water at room temperature and in boiling water. And then we will keep them undisturbed and we will observe the changes.
To study diffusion of a solid in a water at room temperature. B. Boiling hot water. Fill one beaker with tap water at room temperature and the other beaker with boiling hot water. Drop one crystal of potassium permanganate in cold water and the other crystal in boiling hot water. Record your observations in both the beakers for half an hour. Observations. Dense and deep violet color is formed around each crystal. However, the size of deep violet color in hot water is larger than that in cold water. The dense violet color starts diffusing slowly into cold water in the form of colored streaks. Gradually, the solution changes to pink color, which is darker nearer the base of the beaker. In case of hot water, the dense violet color rapidly diffuses to form pink color, which is more homogeneous as compared to that in cold water. The rate of diffusion increases with the temperature. It is because boiling hot water molecules have more kinetic energy and there are larger intermolecular spaces. Thus, the particles of solid potassium permanganate rapidly diffuse and hence rate of diffusion increases. Conclusion. The rate of diffusion of a solid in a liquid increases with a rise in temperature.
So what are the changes that we will observe? So children, as we know that solids, they easily dissolve in water. Think about sugar, think about salt. Do they dissolve in water? Yes, they easily dissolve in water. So they have the capacity to intermix with each other. So that's why the solid crystals like copper sulfate and potassium permanganate starts dissolving in water, forming a beautiful thread-like patterns. As time passes, the crystals dissolve in both hot water and cold water, imparting blue or purple color. As you know that copper sulfate produces blue color solution and potassium permanganate produces dark purple coloration. But my question to you is, can you tell me that which of the particular sample of water, hot water or cold water, in which sample will there be more dissolution? Will there be more mixing or faster mixing? Answer is really easy, right? The answer is hot water. Why? Because in hot water, there will be more energy. If there is more kinetic energy, the particles are moving frequently, so quickly, so fastly that they easily dissolve in it. So what will happen? It takes longer for crystals to dissolve in cold water than in hot water. Because in hot water, there is more energy, there is more random motion of particles, so intermixing is quick or faster. But in cold water, comparatively, there is less energy, there is comparatively less motion of particles and intermixing is less. So can I say that diffusion depends on temperature? Absolutely yes. Higher the temperature, higher is the rate of diffusion. Higher is the mixing of particles with each other. So what is the conclusion? Conclusion is matter is made up of small particles that are always in motion. They are in continuous motion. The rate of mixing increases as the temperature rises. Hence, the rate of mixing of particles increases with increase in temperature or vice versa. I hope you have understood that how temperature affects the rate of diffusion of particles. Thank you. Hello children, let's understand a very important characteristic of particle of matter, that particles of matter attract each other. How can they attract each other? Look at this diagram. What is this? The first arrangement of particles belongs to solid state. The solid particles are tightly packed such that they have rigid structure like my pen, like my remote. Now what about these? See, the particles are a little far apart from each other. They are loosely held. So this arrangement belongs to liquid. And what is this arrangement? This is gas. Because particles are so loosely held that gas tries to escape out of the container if it is open, right? So how they are attracting with each other? See, solids, when they are so close to each other, there is a kind of attraction between them. They are attracted with the neighboring atoms. Similarly here, there is a kind of attraction between neighboring atoms. Yes, there are attractions in the gaseous particles also. But definitely the strength of attraction will vary, right? It will depend whether it is solid, liquid or gas. But can we say that particles of matter are held together by some force of attraction? Yes, even everything around us, every one of us are attracting each other by some kind of force of attraction. So particles also, they have some kind of force of attraction. Think about water. When you see water, do you see any holes in between? No, because the particles of water are attracting with each other so effectively that we can't create any hole in the water. Air, can you create hole in air? I can't. And what about these? They are so rigid and hard that there are no holes in that. Though they have different textures, the surface could be rough, but the particles have force of attraction which are attracting them so effectively that they are bounded in certain boundaries, right? So, can we say that the particles of matter are held together with the interparticle forces of attraction? Different substances have different strength of attractions. What do you think? What about solid, liquid and gas, which has more force of attraction? So, if particles are closer to each other, they have more force of attraction as compared to liquids. The particles are comparatively loosely held, so they are little far from each other, so there is comparatively lesser attraction. But what about gases? The particles of gases are even far away from each other, so though they have the force of attraction, but comparatively less. So gases have least forces of attraction between their particles. For example, can you tear the paper? Yes, I can tear the paper, but not the piece of wood or iron, because those piece of wood or iron, they are held by strong force of attraction, right? So it depends on the strength, the amount of the substance also, that how much force of attraction particles carry. Now, similarly, you cannot tear water. Can you tear water? No, I can't create any hole in water. So definitely the water particles are also held by strong electrostatic force of attraction. So to understand it better, let's do an activity. So what is this activity? To observe that particles of matter are held through force of attraction. So we will prove that. How? Children, have you ever seen the Idumishmi dancers? See, how are they making chains? They are making human chains. So in this activity also, we will be making human chains. How? So we will ask the students to divide into groups. Group A, B, C, D, 4 groups, and create human chains. So group 1 students, they will hold each other interlocking their hands like this. Right? The way dancers interlock their hand while doing the Idumishmi dance. Then group 2 students hold hands to form a chain. Group 3 students touch each other with their fingertips. And group 4 students should move around and try to break the chains. So what are we going to do? We are creating 3 human chains, like the way we do in Idumishmi dancers. They do the interlocking of their arms, or they hold hand in hands. This is the very popular dance of Arunachal Pradesh. Yes. So what will happen? There will be 3 types of chains. One chain will have interlocking of their arms. And second, students will have to hold their hands like this. And in third, they will only touch their fingertips. And the fourth group of students, they will try to break the chain by passing through the interlocks. So they will move around and try to break the chain. What do you think, in which particular chain it is easy comparatively to break it? So the observation is the human chain formed by third group is easiest to break. Which group? The group where the students only touch their fingertips. They are easy to break, right? Why? The conclusion is the students of the third group have formed the chain just by touching each other with their fingertips. So their force of attraction is really less, right? So if we consider that each human is an atom or a matter, they have less force of attraction. They are just touching each other with a fingertip, while the ones which are interlocking, their strength is very high, right? They have greater strength and more force of attraction. So thus there is least strength in this human chain or no bonding force. Hence it will break easily. I hope you have understood that particles have force of attraction between them. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand a very interesting activity. In this activity, what are we going to do? The aim of the activity is to prove that particles of matter attract each other. So in this activity, we will be taking an iron nail, we will take a piece of chalk and a rubber band, right? Try breaking them by hammering, by cutting or stretching. In which of the above three substances do you think the particles are held by greater force of attraction? So in order to understand the activity, let's watch the animated video we have.
To prove that particles of matter attract each other, take an iron nail, a small piece of wood, and a rubber band. Try breaking them by cutting, hammering, or stretching. You notice that the rubber band is the easiest to break, followed by wood and then iron. There are some forces which keep the particles of matter together. However, the strength of these forces varies with the kind of matter in a given substance. This force of attraction exists between the smallest particles of matter and is commonly called intermolecular force.
Children, as you have seen the animated video, a very easy and simple activity it is, right? What are the observations? The observations are, iron nails do not break by hammering or stretching because they are very hard. Cutting also takes longer time for it, whereas chalk and rubber band, they break easily. Why is this so? So the conclusion is, the particles in the iron nails have greater force of attraction. Iron nails have strong, rigid structure. The particles have greater force of attraction such that we are unable to break it, hammer it or stretch it, right? So, as compared to the chalk particles or rubber band particles. So, can we say that different kinds of matter have different strength of interparticle forces of attractions? Yes, think about the force of attraction in chalk, rubber band and iron nail. Which has greater force of attraction? Definitely, iron nail has greater force of attraction. It is difficult to break it or stretch it. While chalk and rubber band, they comparatively take lesser time in breaking or cutting or stretching. Definitely chalk cannot stretch, but rubber band can stretch. I hope you have understood. Now let's also discuss one more interesting activity. So children, in this particular activity, what are we going to do? We will prove that the particles of water, they are also held together by forces of attraction. Yes, even water molecules, liquid particles, they have force of attraction, not only solids. We have already discussed in the previous activity that solids like iron nail, chalk and rubber band, they do have forces of attraction, right? But water is a liquid. Can it have a force of attraction? Yes, the particles have force of attraction even when it is a liquid in state. So, what do we do in the activity? We will take some water in a container. Try cutting the surface of water with your fingers. Were you able to cut the surface of water? Try it at your home. It's so easy. So, when you put finger in the water, will it cut? Definitely no, it will not cut, right? So, the observations are the surface of water cannot be cut. So, what is the conclusion? The conclusion is the forces of attraction between the particles of water held them together. There are strong force of attraction even when the particles are in liquid state. So the water molecules have forces of attraction between them which are holding them together. The strength of force of attraction varies depending on the type of material, whether it is solid, liquid or gas. So if we have to write a sequence, solid, liquid, gas, which particles will have stronger force of attraction? Definitely solids will have stronger force of attraction than liquid, and comparatively gases will have least forces of attraction. I hope you have understood. Thank you. Hello students, let's understand this wonderful question. It's a really interesting question and very important as per examination point of view. So the question says, convert the following temperatures to the Celsius scale. And first is 293 Kelvin, second is 470 Kelvin. So children, I'm sure that you know that the relation between Kelvin and degree Celsius is Kelvin is equal to degree Celsius plus 273. So we already have temperature in Kelvin. So it means we need the temperature in degree Celsius. So what should I do? I should subtract 273 from the Kelvin scale, right? So this is what we should do. We have to apply this formula here. So we have 293. So if we have 293, how will we calculate degree Celsius? It is 293 minus 273. So what should be the answer? Find the difference between these. It is 20 degrees Celsius, right? Now the next is 470 Kelvin. Again, we will apply the same formula. Degree Celsius is equal to Kelvin minus 273. And here the value of Kelvin is 470 minus 273 and we get the answer 197 degrees Celsius. I hope you have understood. Thank you. Hello children, let's understand this wonderful question. The question says, convert the following temperatures to the Kelvin scale. And here we have two parts given, 25 degrees Celsius and 373 degrees Celsius. So we know that the formula is Kelvin is equal to degree Celsius plus 273. So if you have value in degree Celsius, just add 273 to it and you will get the value in Kelvin. So let's begin with the answer. So if we have 25 degrees Celsius, so just add 25 to 273. And what will be the answer, children? 298 Kelvin. So we have got 25 degrees Celsius as 298 Kelvin. Now, when we talk about 373 degrees Celsius, what will be in Kelvin scale? So, put the value to 373 in the formula plus 273 and what you have got? It is 646 Kelvin, right? I hope you have understood. Children, make sure to always write the formula first before applying any value or substituting any value. I hope you have understood. Thank you. Hello children, let's understand this wonderful question. It's a reasoning question. So the question says, give reason for the following observations. First is, naphthalene balls disappear with the time without leaving any solid. Why is it so? Because children, naphthalene can sublime. What is the meaning of sublimation? That it can directly convert from solid to gaseous state without converting into liquid state. So it absorbs the thermal energy from the surroundings, which is sufficient for it to convert from solid to gas, and therefore we don't find any solid material which is left in the naphthalene balls after few days. Now let's talk about the B part. We can get the smell of perfume sitting several meters away. Why is it so? Because children, smell of perfume contains some particles which are aroma particles, right? Because we feel its fragrance. So it contains some aroma particles which easily diffuse. Which easily diffuse into air. So when they diffuse into air, what happens? These particles can easily flow from one point to another and therefore we can smell the perfume particles even when we are several meters away. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand the question. It says, arrange the following substances in increasing order of forces of attraction between the particles. We have water, sugar and oxygen. So we have water as a liquid, sugar as a solid and oxygen as a gas. So do you know out of solid, liquid, gas, which has more force of attraction? Definitely it is solid. Solid has higher or greater interparticle forces of attractions because solids have particles very close to each other, right? As compared to liquid, and gases have particles far away from each other. So definitely if we talk about increasing order, in ascending order from smaller to greater, so we have gases first. Gases have less force of attraction. Liquids have greater force of attraction than gases, and solids have even greatest forces of attraction or maximum forces of attraction between the particles because the particles are closely packed. Now what about water, sugar and oxygen? So on the basis of this particular criteria, which is gas here? Oxygen. Oxygen has less force of attraction than water, and sugar has maximum force of attraction because it is a solid. I hope you have understood. Thank you. Hello children, let's understand the question. The question says, what is the physical state of water at 25 degrees Celsius? We know that at 0 degrees Celsius, water exists as ice, and at 100 degrees Celsius, it converts into water vapors. So at 25 degrees Celsius, it must be in the liquid state, right? Water exists as liquid. Now what about 0 degree? At 0 degree Celsius, it is that temperature when ice converts into water. But at 0 degrees Celsius, still the process is going on. So at 0 degrees Celsius, you will find the physical state of water as ice, that is solid, in the form of ice. And also you will find liquid state, which is water. As we know that 0 degrees Celsius means solid is converting into liquid, ice is melting. So we will get both the physical states at this temperature. Similarly, at 100 degrees Celsius, it's the boiling point of water. So water is converting to water vapor. So when water is converting to water vapor, what is the physical state of water? It is definitely liquid. And if it is converting to water vapors, what is the physical state of water vapor? It is gas. So both liquid and gases physical states will exist at 100 degrees Celsius. Water as a liquid and water vapors as the gaseous state. I hope you have understood. Thank you.
Goyal Brothers Prakashan is pleased to introduce Digi Smart Books, a revolutionary learning experience through QR codes. Your teacher is just a scan away from you.
Hello students, we are going to start the chapter Real Numbers.
Scan to understand every concept, activity, experiment, example, or question given in the NCERT textbook. Scan to understand chapter-wise all types of questions as per latest CBSE exam pattern. Scan to understand every question given in CBSE, sample paper, and model test papers. Bringing learning at home, anytime, anywhere, any number of times. Making learning student-centric. Grab yours today from leading online platforms or nearby bookstores.
Hello children, let's understand this important question. It says, give 2 reasons to justify. First part, we have water at room temperature is a liquid. So why water at room temperature is a liquid? Because water has moderate forces of attraction, right? The particles are not too tightly held or not too loosely held like gases. So it has moderate forces of attraction as compared to solids and liquids, right? So this is the main reason. The forces of attractions are the main reason for having any physical state. So if it is greater force of attraction, it must be solid. If it is loose force of attraction or weaker force of attraction, it must be gas. And if it is in between the solid and gas, then we call it a liquid. Now the next part is an iron almirah is a solid at room temperature. Again, it depends on forces of attraction. So iron almirah has stronger or greater forces of attraction. Why it has stronger forces of attractions? Because particles are very tightly packed. Also, do you see a fixed shape and fixed size? Definitely. So iron almirah has definite shape and definite size. It has definite volume also. So now think about water. Does water has definite shape? No, water has indefinite shape. So it cannot be solid. It has indefinite shape. But does it mean it can be gas? No, because gases have indefinite volume also. But water has definite volume. So it clearly indicates that water is a liquid, but iron almirah is solid at room temperature. I hope you have understood. Thank you. Hello children, let's understand the question. It says, why is ice at 273 Kelvin more effective in cooling than water at the same temperature? As we know that 273 means we are talking about 0 degrees Celsius. And at 0 degrees Celsius, we have ice as well as water, right? Both forms of water or H2O exists. So the question says at 0 degrees Celsius, we have ice as well, we have water as well. But why ice has more cooling effect? Why its cooling is more effective? Children, because ice has more or greater latent heat of fusion. Now think about why ice has greater heat of fusion. Because ice still has to convert into water. So ice needs more energy for that. It means ice has greater latent heat of fusion. So if it absorbs more energy to convert into water state, it means definitely by absorbing more energy, it will create more cooling effect. I hope you have understood. Thank you.
Goyal brothers